Hi guys, see you again in chapter 5, State of Matter. This is the second part of subtopic 5.1, Gas. So guys, let's start. Okay guys, in this subtopic, we are going to learn about ideal gas equation, which is we want to determine the molar mass, number of mole, pressure, volume and temperature. So, what is ideal gas? Ideal gas, hypothetical gas whose pressure, volume, temperature relationship can be accounted by the ideal gas equation. So, this ideal gas also called as perfect gas. So, maksudnya ideal gas ni adalah gas yang sangat sempurna lah, okay? But class, although no ideal gas actually exists, sebenarnya kalau ikutkan yang real, tak ada pun ideal gas yang wujud. Macam kita, manusia pun tidak ada manusia yang sempurna. Most simple gas such as nitrogen, oxygen, hydrogen and noble gas show nearly ideal behavior at ordinary temperature and pressure. Dia ada syarat jugalah dekat sini. Okay, so tak semua gas menghampiri ideal gas. Okay, tak semua, tapi boleh. Macam kita, manusia pun boleh menghampiri kesempurnaan kalau ada syarat-syarat tertentu. Okay, so apa itu ideal gas? Macam mana formula ideal gas? Okay, so ideal gas relate with these three gases law. By combining these three gases law, we can identify, we can predict ideal gas equation. How? Okay, before this class, we know that the relationship in Boyle's law refer to the volume inversely proportional to the pressure, while Charles' law, volume directly proportional to the temperature, and Avogadro's law is volume directly proportional to the number of mole. If we combine all these three gases law, we will got the equation like this. Volume directly proportional to the number of mole and temperature divided by the pressure. So volume and pressure is inversely proportional. So if we want to identify the ideal gas equation, kita nak kena buang tanda ni kan. So kalau kita nak kena buang tanda ni, kita kena add on constant. So you akan dapat nilai dia V equal to nRT over P, di mana R itu adalah nilai constant. So if we rearrange this formula, you akan dapat formula baru, iaitu PV equal to nRT. So this is the ideal gas equation. Okay guys, just now we already identified the ideal gas law from combining the three gases law, which is Boyle's law, Charles' law and Avogadro's law. So we got this a new formula, which is PV equal to nRT. So this is ideal gas equation. Before you use this formula in the calculation, you need to know what is P, V, N, R and T. So we know that awak semua sepatutnya dah tahulah. P adalah stand for pressure, V stand for volume, N refer to the number of mole, T refer to the temperature. But R is universal gas constant. Later, we will discuss more about this universal gas constant. What I want to explain to you about this ideal gas equation, you need to know that the pressure here, before you use in the calculation later, the unit of pressure should be in atm, while the unit of volume should be in liter, and macam biasalah number of mole, and the unit of temperature should be in Kelvin. Tak boleh dalam Celsius, wajib dalam Kelvin. Why? Because of this universal gas constant. Kalau tak, jawapan awak nanti akan salah. Okay? Okay, so universal gas constant R. Tadi kan kita dah tahu kenapa unit P mesti ATM, volume mesti liter, and so on. So this is the reason, guys. Okay, so if you look at the value of R here, 0.08206 liter ATM per mole per Kelvin. So if we simplify this formula or this unit, it should be like this, per mole per Kelvin. Okay, so kalau you lihat formula ni, kan dia dapat daripada standard pressure and standard volume and temperature. Okay, so kita akan dapat nilai R 0.08206. So kalau you refer dalam table relative atomic mass ataupun refer kepada list of constant value, nilai R ni berada dalam list tersebut. So you all tak perlu hafal. Okay, but class, be careful. The universal gas constant values in the list of constant values ada dua. Ada dua kelas nilai. Satu lagi adalah nilai dia 8.314. But this value kalau boleh saya tak galakkan awak gunalah. Okay, make sure you stick pada satu nilai sahaja supaya awak tak pening. Okay, awak boleh pakai nilai ni, but you kena hati-hati dengan unit dalam nilai tersebut. Okay, but for me, better you stick with this value sebab senang. Sebab apa? Sebab volume dia dalam liter, pressure dia mesti ATM, mole molar, okay, dan temperature should be in Kelvin. So this is the reason why the unit of pressure, volume and temperature you need to consider. Alright guys, so now we look at the example of question that relate to the ideal gas equation. So apa yang you all kena buat macam biasalah. Okay, we need to read the question first and then take out the information given in the question. Okay, so kita tengok dulu apa maklumat yang diberi dalam soalan. Okay, soalan nak cari what pressure in ATM is exerted by 54 gram of xenon. So ini adalah noble gas in 1 liter plus at 20 degree Celsius. So kita identify dulu one by one. So this question asks you to calculate the pressure. Nak cari pressure. But we have the mass of the gas. Kita ada mass. So ini adalah mass of xenon. And then we have the volume. Dah ada dalam liter. Kemudian kita ada temperature. But be careful guys. Kalau awak tengok maklumat yang diberi ni must relate with the ideal gas equation. PV equal to nRT. Nampak tak? Okay, sebab apa? Kita nak cari P. Kita ada volume, kita ada mass, kita ada temperature. So temperature dekat sini mesti dalam Kelvin. Macam mana nak convert? So 20 plus 273.15. Okay, so and then press your calculator. So you will get the temperature is 293.15 Kelvin. So ini adalah nilai temperature. Okay, but pressure nak cari, volume dah ada kan, temperature dah ada, R pun dah ada dalam list of constant value. Macam mana dengan M? Macam mana nak cari M? Kan kita ada mass je kelas. So how to calculate number of mole? We know that to calculate the mole of xenon, kita kena bahagikan mass kita dengan molar mass of xenon. You kena dapatkan daripada periodic table ke ataupun list of constant value. So ini adalah molar mass of xenon, and then if you press your calculator, you will get the mole of xenon is 0.4113 mole. Okay, so ini mole awak lah. So kita dah dapat nilai N. And then how to calculate the pressure? So if you rearrange this formula, P equal to nRT over V, and then you substitute all the value here. Masukkan nilai. So awak boleh dapat, awak kena cancel out unit dia kan. Unit yang sama tu kita cancel out kan. Okay, kemudian awak akan dapat nilai pressure dia adalah 9.89 atm. So ini adalah final answer. So final answer class, be careful. Final answer must insist unit. Mesti ada unit, wajib. But during your calculation here, kalau you tak nak masukkan unit, tak ada masalah. Okay, tak ada masalah. Boleh je terus kira. But you need to know the unit of pressure should be atm, because based on the R value unit. Alright, boleh. Next, we look at the further application of ideal gas equation. So kita ada lagi formula yang relate dengan ideal gas equation, di mana calculation of gas densities and molar mass. So we can simplify ataupun kita boleh ubah formula PV equal to nRT kepada formula yang kedua dan formula yang ketiga yang boleh relate dengan gas densities dan juga molar mass. Okay, we look at the first one, molar mass of gaseous substance. Okay, just now we know that the formula of ideal gas is PV equal to nRT. Okay, so kalau kita nak relate dengan molar mass, kita mesti tahu formula number of mole. So mole equal to mass over molar mass. Ini adalah formula yang you all biasa guna since school lagi kan. Alright, so kita akan modify formula ideal gas equation dan kita akan masukkan formula number of mole ni. Okay, so saya akan rearrange the formula become like this. Number of mole equal to PV over RT, and then kita akan substitute formula number of mole ni ke dalam N. So, you all akan dapat mass over molar mass equal to PV RT. And then, saya susun formula ni untuk jadikan molar mass sebagai tajuk utama dia kan. So, molar mass equal to MRT over PV. So kita dah dapat formula yang baru untuk relationship ideal gas equation dengan molar mass. Next, we look at the relationship of ideal gas law with gas density. So we know that this is the original formula of ideal gas, and just now kita dah dapat formula yang kedua that relate ideal gas with molar mass, which is molar mass equal to MRT over PV. Alright, and now if you still remember in school, we have the formula of density, which is the density equal to mass over volume. Still remember? So now guys, kita akan simplify this formula, become a new formula di mana mass over volume here refer to the density of gas. So you akan dapat formula baru di mana molar mass equal to density RT over P. So kita ada 3 formula that relate with the ideal gas equation. So you boleh guna 3 formula ni bergantung kepada soalan atau maklumat yang diberi dalam soalan. And now we look at the example here. Okay, so as usual class, we need to read the question carefully and look at the information given in the question. Okay, an organic chemist isolate from a petroleum sample a colorless liquid with properties of cyclohexene. He obtains the following data to determine its molar mass. So the volume of sample gases. So dia dah bagi dalam soalan adalah volume of gas, and then you ada juga mass of gas, and we have the temperature and the pressure here. Okay, daripada maklumat yang diberi dalam soalan ni, dia nak cari molar mass kelas. Dia nak cari molar mass. So kita tahu, kita dah ada formula molar mass that relate with ideal gas equation. Okay, so we know that ideal gas equation that we have is PV equal to nRT. So if we modify this formula, you akan dapat molar mass equal to mRT over PV. Okay, now we look here. Based on the information given in the question, mass of sample kita dah ada 0.582 gram. R is universal gas constant, so you can find out from the list of constant value. And then the temperature, so we have 100 degrees Celsius here, but be careful, the temperature, if you use the ideal gas equation, must be in Kelvin. Yang ni mesti dalam Kelvin, so you kena convert dulu dalam Kelvin. And then pressure we have in torr, 754 torr. Macam mana nak convert torr jadi ATM? So you kena divide dengan 760 torr, dan you akan dapat nilai pressure dalam ATM. Okay, if you refer to the list of constant value, 1 ATM equal to 760 torr. Okay, so if you want to convert torr to ATM, you need to divide by 760 torr. And then the volume that we have here in milliliter. Be careful guys. The volume here should be in liter. So and then baru you boleh masukkan all the value in this formula and then press your calculator. So you will get the final answer should be 84.4 gram per mole. This one I want you to try it by yourself. Okay, cuba buat, masukkan semua nilai, dapatkan jawapan ini. Boleh? Okay, that's all for the second part of subtopic 5.1. Thank you.